All right, we're going to talk about the properties of a special parallelogram. Specifically in this video, we are going to talk about the rhombus. So a rhombus starts out with all of the properties of a parallelogram, and we're not going to list those here, but opposite sides are congruent, opposite sides are parallel, the diagonals bisect each other, opposite angles are congruent. All of those things you learned earlier in this chapter, those are already automatically part of a rhombus because it is a parallelogram. In addition to all of the properties of the parallelogram, we get 4 additional features. The one that most of us know are that all 4 sides of a rhombus are congruent. So all 4 sides are equal. It's kind of like a square that's been tipped on its side. We also know that each of the diagonals is a perpendicular bisector of each other, and that's rooted in our equidistance theorems. We have points that are equidistant from endpoints in both places. So that creates perpendicular bisectors of each other. Both of the diagonals bisect the opposite angles. So this diagonal GO bisects these angles. Now remember, they were congruent because the opposite angles in a parallelogram are already congruent. EM bisects angle GMO and angle GEO. And again, they were congruent to start out with because of the property of a parallelogram. And then the very last feature is kind of just like a bonus. It's not something that we talk about a whole lot or that we address or think about, but it's just like a bonus feature. We end up with 4 congruent right triangles in a rhombus. So we know that this right triangle here is congruent to every other right triangle in the picture because of HL, because we have at least the hypotenuse are all congruent by the property of a rhombus. We have a right angle because we have perpendicular bisectors, and then we at least have one leg. So by HL, all 4 of the right triangles that you see there, so 1, 2, 3, 4 right triangles, they're all congruent to each other.